let us discuss the isomerism exhibited by another 5 compounds. 26 is the iron in the form of ferric, that complex. Here what happened, 4 plus 2 coordination number, the coordination number is 6, and the format is M, for example A to B4. Definitely it will exhibit geometrical isomerism, and that too cis and trans. Cis transmerism, isomerism, what I have already explained, the position of trans 1,6 is taken as what's called the trans. So Fe NH3 twice CN4, that exhibit geometrical isomerism under what's called the stereo isomerism. Now next, compound number 27, and here the oxalato, dioxalato. So oxalato, the 2 ligands are there, and then chloro ligand, and this has the total coordination number, that is Cn is equal to 6, and again octahedral, what's called the octahedral geometry. Since the bidentate ligand is involved, definitely it can exhibit what's called the optical isomerism. Optical isomerism under stereoisomerism. In optical isomerism, the molecular symmetry, so we have to take into account. And in compound number 28, and here the important point is, you see the counter ion chloro, and the nitro is inside. And this complex, for example, 5 plus 1, 6 is an octahedral complex, so coordination number 6, and it can exhibit for structural as well as stereoisomerism. So in structural isomerism, what happens, for this NO2 can go outside and one Cl can come inside. So when NO2 go outside and Cl come inside, and that will result in the different type of what's called the ionization. Therefore it can exhibit ionization also, ionization isomerism. And one more thing is this NO2, if nitrogen is linked to the central metal, we call it as nitro. On the other hand, if oxygen is linked with the cobalt, at the time we call it as what's called this nitrito. So this another example, what's called the linkage isomerism. So linkage isomerism also possible. So ionization isomerism and also linkage isomerism possible in what's called the compound number 28. That's the cobalt complex, and it's the octahedral nature. And optical isomerism is ruled out here because no bidentate ligand is involved, and cis trans also it is not recommended here because the format is not either Ma3B3 or Ma4 B2 type. Therefore we restrict the isomerism to structural, ionization and linkage. And number 29, and here what happened, the 2 complexes are involved and the exchange of ligands can take place. This amine can go to the other side and cyano come inside here, and this type of isomerism called coordination isomerism. So coordination isomerism is possible, and coordination isomerism involves exchange of ligands between the central metal ions. When Cn comes here, that is the cobalt is linked with the cyano, and amine goes there, amine is linked with what's called the chromium central metal ion. And number 30, and here again sulfate counter ion, here bromo. If bromo goes outside, that's called bromide, and the sulfate comes inside, that's called sulfato. And this particular compound exhibit what's called the structural isomerism. Under structural isomerism, what's called the ionization isomerism possible. So ionization isomerism in what's called in compound and number 30. So cobalt complex, ionization is what's called the ligand moving out of the complex, and ligand then will be called as what's called the counter ion, and the counter ion comes inside the complex, that will be again named as ligand. When sulfate comes inside, it is sulfato. When bromine goes outside, it's called bromide. And I repeat all the what's called the type of isomerism here in 26, geometrical cis trans, and 27 octahedral geometry, and there is optical isomerism possible because of the bidentate ligand oxalato. So in the picture or in the book, it is given OX, better read it as oxalato, substitute that OX with the C2O4, make that correction in the book. And 28, and here also octahedral complex, coordination number 6, and ionization and also as well as linkage, 2 isomerism possible because NO2 and ONO, at that time it's called linkage isomerism. When NO2 goes inside, outside, Cl comes inside, at that time ionization isomerism possible. 29 coordination and 30 ionization isomerism. And the next session is regarding the chemical bonding. we have to mention the type of hybridization. Let us move on to that section 3.